Explain the video goal and say this will cover what cloud storage is, the main service models, public, private. Google Cloud One. Give a simple definition of cloud storage, a remotely hosted service that stores data on provider-managed. Mention that cloud storage can be offered as object storage, immutable objects plus rich metadata. Block. Describe the core architectural building blocks at a high level, front-end API/gateway that handles authentication. Emphasize separation of control plane, metadata, policy, and data plane, actual bytes. Google Cloud One. Explain durability and redundancy conceptually. Cloud storage achieves high durability by storing multiple. Discuss trade-offs between simple replication and erasure coding, storage overhead versus repair bandwidth, and how. Use examples like multi-as object replication as an architectural pattern for durable data. AWS. Cover APIs, protocols, and compatibility at a high level. Explain that object storage commonly exposes RESTful APIs. S3 compatible APIs are de facto standard across. Mention why S3 compatibility matters for tooling, backups, and ecosystem integration. Architecting IT4. Discuss storage classes and lifecycle policies. Describe hot/warm/cold/archive tiers. How lifecycle policies choosing tiers. Mention retrieval times and cost implications for archive classes in general terms. Explain consistency and performance trade-offs. Introduce eventual versus strong consistency for object reads after writes. How some systems guarantee read after write for new objects while others expose eventual visibility, and how caching, CDNs, and edge nodes reduce latency for global users. Describe metadata, indexing, and search at a high level. Show how object keys, user metadata, and indexes allow fast lookup, and how metadata services must scale independently of object stores. Touch on versioning and immutability features. Object versioning, worm/retention, useful for backups and compliance. Cover security and access control simply. Explain authentication and authorization models, IAM, ACLs, signed URLs, encryption in transit and at rest, customer-managed keys versus provider-managed keys, and logging/audit trails for access. Mention common regulatory concerns like GDPR, HIPAA, and region data residency without giving legal advice. Mention common deployment choices and integrations. Use managed public cloud services for most needs, or hybrid architectures where on-prem appliances sync with cloud buckets for low-latency local reads. Integrate with database backups, analytics pipelines, ML datasets, and CDN for delivery. Provide safe learning paths and resources. Point to cloud provider docs and tutorials for object, block, and file storage. Read provider white papers on durability and encryption. Study distributed storage design patterns and system design resources, and practice with managed services and local S3 compatible emulators before designing production systems. Google Cloud One. Summarize the core ideas. Cloud storage is a set of scalable services exposing APIs to store and retrieve data. Designs balance durability, cost, latency, and consistency. Security, lifecycle, monitoring, and testing are essential, and most real deployments prefer managed providers or validated appliances rather than building raw storage clusters from scratch. Google Cloud One, AWS documentation 3. Visual suggestions for the video input. Show a simple animated diagram of a client calling a storage API to put and get an object, with the request passing through an API gateway to a metadata service and then to multiple storage nodes. Show split screens comparing object, block, and file semantics in typical use cases. Show an animation of erasure coding or multi-as replication to illustrate durability. Show overlays for encryption in transit and at rest and IAM role examples. No credentials shown. Show charts comparing storage classes, cost versus access latency, and a dashboard of monitoring metrics and billing alerts. End with a call to action. Study provider docs, prototype with managed services, and practice the AI and security audits before trusting any design in production. Storage systems work in the architectural, security, and operational considerations for building or choosing them. Storage in AMP. How does it work? Google Cloud. 2. https://cloud.google.com/discover/object versus block versus file storage? Up_source equals chat.com how